So here's a problem like number 8 and 4.6 out of my open math, or on page 248, number 13. And that's actually, this is number 13 from page 248. Alright, so they're telling us a little bit of information. I wrote them as an ordered pair. So I know after 10 minutes, so X is 10, or T is 10, and the population is 800. And then after 40 minutes, the population is 1800. So the first thing they want me to find the initial size, which is A. So I just used a annual growth model. I said 800 equals A times B to the 10th. So, and then I did 1800 equals A times B to the 40th, and I solved both sides for A, just like we were doing with an equation with the points. And when it sets these are both equal to A, we'll set them equal. Then we'll write the cross products. And there's a lot of ways to tackle it. I think what I'm going to do is I'm just going to set it equal to 0. Then get a GCF of, I don't know, 200 B to the 10th. So this factors to 0. That's right, because the only way this is equal to 0 is if B equals 0. Now some of you might want to divide back up here, might want to divide both sides by B to the 10th, and really it'll get you the right answer. This idea of having the GCF, it's, I don't know, it's kind of an extraneous root, so I guess it'd be okay to go that way, divide by B to the 10th, though I'm always nervous when I'm dividing by a variable. I might lose a possible answer. So anyway, so now 0 is one of the answers, but that wouldn't make any sense because that's we're trying to solve for A. So there's this other one, and what we're going to do is we're going to take write it up here. 4b to the 30th minus 9 equals 0. So basically, we're going to have to do the 30th root of 9 divided by 4, and that's what b is. So then to finish this off, I know that the 30th root of 9 over 4 according to my calculator is about this value. And then since I have these two equations where I've solved it for A and I want to find A, that initial value, I just chose the first one. I'm going to do 800 divided by that number to the 10th power, and I won't show you that on my calculator, but that's what I'm going to do. I'm going to do 800 divided by that answer to the 10th power, and I got 610, let's see, I got 610.5, so since this is a population of individuals, I guess I'm going to go with 610 as being the initial value. Okay, it's actually a little bit more than that, but you can't have half a person or half a item or half a whatever, so that's A. So I'm going to put all those pieces that I've solved together and write the equation. Now they're asking, question B in this is asking for the doubling time. So basically that's asking me when is this population of bacteria equal to 220 or 1220. That's 2 times what 610 is. Well, when we divide both sides by 610, we should give me 2, and that is a shortcut we can always take when we're looking for doubling time. Also half-life too. When you're looking for half-life, you can just write 1/2 over here. So now to solve this, I guess I'm going to take the log or natural log of both sides. I'll go with log. So the log of 2 equals, and I'm going to use that power rule when I'm taking a logarithm. I can bring exponents out in front. So then I'm going to take the log of 2 and divide it by the log of that 1.0274. And that should be the doubling time. So for part C, you're just going to take your equation, replace t with the 105, and then calculate that on your calculator, and they should follow the order of operations, and you probably want to round to the nearest whole number. I would maybe round down. Depends what my open math wants. Then to get to part D, when will the population equal 11,000? Well, you're just going to set your equation. 11,000 equals that 610 times 1.0274 to the t. We're going to solve for t. So to solve for t in this case, or to solve part D, I got to equal 11,000. I divided both sides by 610, came up with that, and then I'm going to take the log of both sides, and then I can bring the t down in front using that log property. And I divide both sides by, I divided both sides of this equation by the log of 1.0274. Important to remember to take the log of it. I've done that before. Okay, so at about 107 minutes is this? I don't remember. Okay, I hope that helps.